Hello, this is exercise 7 from data structures on algorithm, and in this exercise we are going to see two types of sort, merge sort and quick sort. So first let's see merge sort. In this I have created a function, in the merge sort I have created a function called merge, which will merge the arrays, and it is having arguments. First argument is an array of type integer, the left index, the middle index and the right index, which is L, M and R. Inside this function I have initialized I, J, K, and I've initialized n1 equals to m minus l plus 1 and n2 as r minus m. Then I've created two arrays, the left array and the right array, and the left array is of size n1 and right array of size n2. And I filled these array respectively. The left array I filled from 0 to n1 using a for loop, and the right array which goes from 0 to n2, and the elements are stored from the main array. I've initialized I equal to 0, j equal to 0 and k equals to l. Using a while loop, I've checked if I is less than n1 and j is less than n2. This function will go till this condition satisfies, and inside this, if I've given if L of I is less than or equal to R of j, then array of k equals to L of I, and I've incremented the I. Else array of k equals to R of j, and I've incremented the j. Finally, I've incremented k by 1. In the next while loop, I've checked if I is less than n1. If so, then I've given array of k equals to L of I, and I've incremented I and k together. In the third while loop, I've used while j is less than n2. I've given the value of array of k equal to rj. Then I've incremented j and k by 1. In the next, I've created a function called merge sort, which will accept three arguments: int array, int left index, and right index. And I've checked if left index is smaller than right index. Then I've calculated the medium as L plus R minus 1 by 2. Then I've called the recursive call to the merge sort of array of left till middle L comma M, and merge sort from array of middle plus 1 till R. Then I've called the merge function, which is from and I've given the arguments ARR, L, the middle and the right index. Then I've created a function called print array, which will print the array, which accepts two variables, an array and its size. And I've used a for loop to print the array. In the main function, I've asked the user first to enter the size of array, and I've stored it in n, and I've created an array of size n. Next, I've asked the user to enter the elements one by one, and I've stored this in the array. Then I've printed out the original array, and I have called the function merge sort, and I passed the name of the array and its start index, that is left, which is equal to 0, the second n, and the third as -1. Next, I have called n minus 1. Then I have called cout equal to sorted array is, and I have printed the new array. So let's check the program. If I run, I give as the size of array as 5. Now let's enter the elements as 1 by 8, 3, 20, 1 and 6. So the given array is 8, 3, 20, 1 and 6. Now we see the sorted array as 1, 3, 6, 8 and 20. So a merge sort runs correctly. Now let's go on to the quick sort. Here first in this quick sort I've created a function to swap two elements, which and using pointer references. This is a simple function. In the main, the next function is the partition function, which takes an array and it takes start and the end. Inside this function, I have initialized a pivot, a variable pivot, which points to the end of the array, and I have initialized I equals to start -1. Using a for loop, I traverse from j equals to start till end, and I check if ARR of j is less than pivot or equal to the pivot. If so, then I have incremented I, and I've given that I'm swapping these two elements, and I have swapped the corresponding element. So let's comment these line outs. Once this loop is finished, I've swapped the last element and the element which is in the current iteration. This will swap the pivot and the current iterated element. I've also given a message of swapping. Let's comment this. I've returned I plus 1. Next, I've created a function called quicksort, which takes again an array, a start index and the end index. And I've checked if start is less than end, then the pi equals to pivot equals to partition of. I've called the function partition and I've passed an array, the start index and the end index, and I've recursively called this quicksort, which goes from start till the pivot element, and then quicksort again called the quicksort recursively, which goes from pivot plus 1 till the end. In the int main function, I have asked the user to enter the size of array, and I've created an array of size n. Then I have used a for loop and asked the user to enter the elements one by one, and I've called the quicksort function which I created earlier. Now I've printed the new sorted array using another for loop. So let's run this program. So I ask for the, let's give the size this time as 6, and I enter the elements one by one. I'll give 7, 1, 9, 3, 5, 2. So here we can see the sorted array is 1, 2, 3, 5, 7, which is in a sorted way. So a quick sort also runs correctly. So this is the end of the 7 exercise. Thank you.